I think it's clear, right? So number one is clear. Um, Differentiable. Okay. Okay. Number two. Um, A is square cube of 1001 and 1 over 4.002. So first, use some choose some functions, choose some number that easy to calculate. Number A will be 10.003, or you can just write the fractions 10 plus 1 over 300. That's okay. Uh, Number B should be 1 over 4 minus 1 over 2000. It's around 0.2495. Okay. And number three, uh, if you check the limit, okay, it's in the indeterminate form. Um, you can rewrite the form, and it will be uh, also in indeterminate form. Okay, which means uh, from here, this is actually 0 over 0 situation. Okay. Then you can use L'Hopital rule. You can use L'Hopital rule, still 0 over 0. One more time L'Hopital rule, you get this. Okay, and you can check the 0, check the number, and you get one half. Okay, number 3A. Number 3B, if you check the form, is it indeterminate form? Okay, but actually you can just write with some proof or some words. Okay, that if you have e to the x and you have x, okay, this function is always greater exponentially, right? So when you check with some numbers, okay, if your number one, so if x1, x2, x10, x100, x1000, you can see that the e to the power with any number, it will always much larger than x itself. Okay, so from this conclusions, you can say that this is actually the limit doesn't exist. Okay, okay, okay. Number four. Okay, number four. You can write g prime is minus sine inverse, and then you need to derive the sine inverse. Okay, the sine inverse will be 1 over square root of 1 minus x squared. Okay, and okay, this is also okay. If you have sine inverse of x, it is x, right? Okay, remember that. Okay, every function, if you put the inverse inside the functions, it will be just x. Okay, then the answer will be a. It's minus x over square root of 1 minus x squared. The number b, I think most of you can do number b, right? You can do this number b. Okay, so this is just a product rule, and you get the answer is also a. And number c, okay, okay, number c, you can do it implicit. Okay, okay. So for number c, okay, number c, you can do with the implicit differentiation. Okay, make y equals secant x with the power of x. The differentiate both sides, you get and make ln y and differentiate. Okay, so ln y will be 1 over y dy dx, and this whole thing should be the product rule. Okay, so this also product rule. So you get the answer is b, secant x x tangent x plus ln secant x. Okay. And number 5. Okay. Number 5. Okay. First, we need to prove P is the midpoint of the tangent line. Okay. So maybe we need to have some number A at point P. So let's say A, because our hyperbola is y c over x, right? So we can have the y is c over A here. Okay. And then first we can check the slope. Okay. Check the slope. The slope is negative c over a squared. Okay. And then we can put the slope inside the tangent line at P. So this is tangent line at P. Okay. So we get this equations. Okay. So because the tangent line, if you see the graph, it will cut here and cut here, right? So we check the intercept. Okay. Check the intercept. So setting x 0, you will have your y is 2c over a. And setting y is 0, you get x is 2a, which is twice of your p, right? And then you, based on that information of the intercept of x and y, so it's proven that p is the midpoint, which is half of the 2a over 2 and 2c over 2. Okay? And then the triangle area, because we know the base and height, it is the 2a and 2c over a. It's always 2c. Because c is constant, the area always constant. Whenever p, so if you change your p, okay, if you change your p, maybe here or here, the triangle will also change, right? But it will change in proportional with c. So it will be always 2c, so always constant. Because when you bring p here, it will getting longer here but shorter here, right? If you're getting over there, the y will be longer, the x will be shorter, and it will always be the same proportion. So it is also proven that the area of triangle is having a constant area. Okay. Okay. Um, Number 6. Uh, this is a ladder problem. So you have L, the ladder. It will be going down with some velocity. We say here is 0.15, and this is the other velocity is 0.2. Okay, and then we can relate with the Pythagorean. We try to find the related rates from here, and we can conclude from here our y. Okay, the y is 4. Okay, and then from the Pythagorean, we have is 5. Okay, 5 meters. Um, and then the question is asked, how fast the angle is decreasing, right? How fast the angle will be reduced. Okay? So because the ladder will be going down, so the angle will be reduced. Okay, we can have two approach. Okay, we can have two approach. We can check with the cos. We can check with the sine. Both will be the same answer. The same answer, negative 0.05 radian per second. Okay? We can use on based on previous information that our x is 3, our y is 4, okay? But we need to check from y and x when they are changing, okay? When they are changing, meaning we need y and x as a variable, okay? So first we get from this x over 5, so we get negative sine theta, okay? And negative sine theta from our informations before previously, sine theta is just 4 over 5. And cos theta is 3 over 5. Okay? So based on these two informations, we can just use the information inside both of our equations. So first, if we use the cos theta, our answer will be negative sign, d theta over dt, 1 over 5 dx dt. Use the information from previous questions, and then you get 0.05. Okay. Similarly, if you are using the sign, you will get cosine d theta dt 1 over 5 dy dt. So the question is asking how fast the angle is reduced. Okay. So it's asking the d theta dt. Okay. And then you get 0.15 divided by 3, which is 0.05 radian per second. Okay. Okay. Uh, I hope you get good score. Okay, in your quiz. Okay. Okay, and also as a reminder, uh, November 20th will be your midterm. Okay, so Friday, next Friday, 20th, chapter 1, 2, 3, and 4. Okay, so meaning we will include all the chapter 4, the graphing, first derivative, second derivative test. Okay, and next week I will finish chapter 4 and maybe going to chapter 5. Okay, yeah. So I will finish chapter 4 and then moving to chapter 5 next week. Yeah, not included. Okay, any questions? Any questions? If there is no question, then I will finish the class. Okay.